Okay, if you guys have the whale, then that's the beginning. It's just a
You know what's
presentation.
interesting is, oh wait, never mind, this is the wrong. Okay, so we just clone this down.
Yeah, we'll start by getting it closed. Uh, I see that, okay. So who knows what Docker is? Jared, don't answer.
It's Jared's favorite tool.
Yeah.
Is that enough of a definition?
Yeah.
Okay. It's okay.
No.
You can, okay, so I'm gonna borrow from Jared's slides. He actually gave an XOIT on Docker, and his slides are gonna come in very useful.
Yeah.
So Docker is basically a way of creating a level of abstraction and isolation onto a given application. In other words, if you guys are familiarized with virtual machines, in which you can create a virtual machine that has everything it needs to run, and that virtual machine is living inside of a host operating system. That virtual machine is just an abstraction layer, it's a file, but you can take a snapshot of it, you can bring it down, you can make copies of it and clone it, and literally you would have different virtual copies of that virtual machine hanging around. Essentially, when we go into Amazon or when we go into Heroku and spin up instances or dynos, what's happening, we don't actually have a little elf that is grabbing a rack, putting it on a rack, and then putting cables really quick and then clicking enter on the screen. It's actually a very big machine or collection of clusters of machines that start spinning out virtual machines. Usually in what they, and those virtual machines are, I'll call them virtual machines. So I'm going to show this little graphic here. The left part is what a virtual machine architecture, so to say, or setup looks like. So there's a server, there's a host operating system, there's a layer that's called a hypervisor that is what manages the virtual machines. And then on top of that hypervisor, you mount your virtual machines and you configure them with whatever you want. If it's you can make it a Mac OS, a Linux, Unix, OS Plus for
Windows also.
Windows, of course, and put different hardware and memory configurations. So what this allows is to have a very granular management of the computing resources. It also gives the ability to be able to control with software the spinning up of instances of computing resources and instances. And the benefits are that you suddenly, before you had to put a server, you had to get some DevOps guy to install an operating system, and then you would be uploading your application on that server. Sometimes the server is not right sized. Sometimes it would take a ton of time until your DevOps guy would get the server, and you know the whole thing. I mean, you guys work with Heroku and understand the benefits of this whole thing. So Docker is one of the platforms that we have for containerization. And what is containerization? Containerization is kind of the next step in virtualization. And what that allows you to do is to create an even the minimum expression necessary for an application to work. It provides Docker provides a platform in which you can build these small containers and you can define exactly the resources that you need, what application is going to go in there, and it gives you the ability to have a lot of scalability and repeatability because essentially you can upload a container into a host that has the Docker engine and then say, okay, put me 4 of these and load balance them on real traffic, or bring all those down and then put a new one. And if you need to take the maximum advantage of that host server, you can do it by right-sizing your Docker container. And essentially, it also strips away the problem with dependencies. So let's say that before in one of your host computers you had Ruby version 1.9, and suddenly you need to upload a new version of your application that has Ruby 2.2.4.2, right? In the case of Heroku, we don't have this problem, right? But in the case of another platform, like for instance in AWS, just using an EC2 instance, like you would have to take care of installing all of those instances in that virtual machine, all of those libraries in that virtual machine. You would have to update your Ruby, do your bundle and all that, and there is no guarantee that you will have a repeatability of results. Whereas in a container, because you got this small unit, you can work on it on your laptop, you can upload it into a continuous integration environment, or you can upload it into the platform that is hosting your containers, and you have a greater guarantee that the results are going to be, the repeatability, you're going to get the same results. It's going to be repeatable. So any questions so far?
So in that image, the blue on the right image,
Yeah.
the blue and the orange and the blue and yellow, that forms a single container. So like app A and app A dash, and that orange, whatever binaries and libraries that those apps need. Does that form a container, or app A is one container and app A dash is a separate container?
App A and App A dash are separate containers. What that is illustrating, I wouldn't mind the orange and yellow for now layers, because that is kind of an option that you have, that you can share libraries between containers. But for now, focus on Docker Engine, the green, and then the blue one. So you got, in this case, you got two applications. One application which is spawned over, application I is spawned in two containers, right? App A and App A dash is the same application, but it's spawned in two containers. One is the copy of another container.
Mm-hmm.
You simply said, okay, this is my minimum expression, but because of scale, because of the traffic, I need two instances of this. Just like in Heroku, you said I need 3 or 4 dynos.
Mm-hmm.
So you tell it, okay, just give me 2 copies of this one.
Okay.
In the case of B, that's 1, 2, 3, 4, it's 5 copies because it needs more scale.
Okay.
But what that is illustrating is that I accommodated 2 applications with different resource requirements in one single computer, in one single server, not computer, in one single server.
Mm-hmm.
So that is the maximum utilization of the resources.
Okay.
So far so good.
Where did the guest OS go? Is the Docker engine handling the guest OS, or is that just omitted for clarity's sake?
Where do you see guest? Oh, guest. Yeah. Well, what that is doing. So to clarify, when you spin up a container, 99.9% of the time, that is kind of a self-contained computer. It's going to have its own OS. It's going to have with the amount of resources that you, and libraries that you require for the OS. Jared.
I was gonna say, usually the first layer of those containers is like either an Ubuntu OS or something similar, like a really light, like Alpine Linux or something.
Okay, so it's just omitted from the diagram.
It is omitted from the diagram. The application.
Themselves usually.
Yeah, the application, the container is self-contained, and the diagram in the left is just illustrating that when you have the virtual machine, that virtual machine is going to have its own OS. So in that case, you could have, just to illustrate, you could have a Windows, a Mac, and a Unix virtual machine running in the same server. And on the right side, you could also have containers with different OSs. It's just that the abstraction is more about the application as being self-contained and not so much as exposing the OS as a resource.
Mm-hmm.
So that is kind of what's going on. Okay, so I'm going to go to Jared's slide that I think were very well illustrated. So in Docker, we have these concepts. We got images, which is the snapshot of a state of an operating system after a given set of instructions have been run. Essentially, if each one of these little blue guys is a container, each one of them has an image. So what we are building when we do Docker, we actually build an image, and that image is instantiated into a container.
Yeah, we have 2 images here, right? And the A and B are both separate images instantiated like B has 5 instantiated containers, A has 2 instantiated containers.
Okay. And containers should be thought of as instantiation of images, sort of like virtual machine snapshots. Like we said, we can scale it to n instances, and they will be completely identical. And then we got what is called a Docker file. A Docker file is just a set of steps. It's sort of like a configuration file or like a YAML file where you say, okay, Docker, I need you to build me an image that's going to have these characteristics. It's going to have this operating system, and I need you to copy over these libraries and set up these environment variables and run a series of commands in it. It's all of the instructions it needs to build the image, and they're concentrated onto a single file. So we're going to make a small pause, and we're going to look at this awesome application that I just downloaded. We're going to just, if you haven't bundled, please do so. I'm going to run it natively. And actually, I should also bring up the application code so we can look at it. Okay. Open it on a new window. So once you've bundled, I'm gonna run a server, and this is all running locally. And what this application has, if you go to the Chuck's endpoint, this is some very important information that you should know. If you refresh, it'll give you another Chuck Norris important fact. I never knew so much. Chuck Norris was so powerful. Actually, in Argentina, we have a similar joke for a soccer player that is not the one. It's not Messi, but it's the other guy that clears the way for Messi. It's like so powerful that we can say that he can mine bitcoins with his brain, kind of thing. So it's this kind of joke. But, okay, so that's our application. Looking at the code for a second, it's a very bread and butter Ruby app. It has a resource, a controller, and a model that just spins out those crazy jokes. So here's what we're gonna do. We're gonna take a look at, open the Docker file that is under the build. Is it under the, yeah, under the build directory. Can you guys see well there?
I'm still doing bundle actually.
It's okay, just go to the code. So
Where's you said it's the build directory?
it's under the build directory.
Alright.
So this file is gonna tell the Docker daemon. By the way, the Docker daemon is the process that manages all the Docker stuff. I'm speaking in caveman terms.
Mm-hmm.
So it's a process that is resident in the host OS and manages all the Docker commands, the container, spinning up containers and building images.
Does that come from the engine, the Docker engine?
I believe so. I can find out more for the next session, but for now, let's say that the Docker daemon takes care of all our Docker commands. So if you see the first entry into the file, number 1, it's saying from Ruby 242. So what is that? When you tell Docker to build this image, it's going to say, I want you to build this image from a pre-existing image that's called Ruby 242. It's called Ruby, and the tag is 242.
Are those stored in some sort of Docker?
Yeah, that's a great question. So I'm gonna show you guys this diagram here.
Docker port? That seems like the appropriate metaphor.
It's called, so if the image is not present into the host operating system, it's gonna go look for it by default into the default repository. So Docker has repositories like GitHub that allow you to store. You can have private repositories, you can have public repositories. So that's amazing because a lot of people contribute to these repositories, and you can download almost anything from OSs, different versions of the OSs that are prepackaged with stuff you need, and even
Perhaps Ruby, Ruby user, really.
what's that?
I will always cover.
Can you repeat that?
But after this, we can take a look at the Ruby.
Yeah, sorry, there was a, so take a look at the Ruby image in the Docker Hub.
Yeah.
Yeah.
Okay,
That's what
you found it? Yeah.
Ruby
So
official.
so
And there is Ruby unofficial.
so Robbie found the.
Ruby official.
So if you guys go into Docker Hub, you're gonna see there's a series of images here that have different tags
Yeah.
that.
You got a Docker file there they use.
So we're saying get Ruby 242, and that is essentially this one here, this tag here.
If you look at Docker file, they're probably using a different a base image as well.
If you click on the thing, it actually links you to their Docker file, and if you look at their Docker file, it's saying okay, build this image from another image that's called build back deps Jesse. That must be a version of Linux.
You have these layers.
How did you got to this?
So if you click on the tag, on the 242 tag, like here, you see where I'm clicking?
Okay.
That's the tag. That's the image. I mean, no, that's the tag. Images are divided into the name and the tag. The tag is like different versions of the image. So I'm clicking on the 242 tag, and it takes me, it links me.
From this page where. So I'm listening here, I'm seeing all the tags.
Click if you can't click on the tag. So go to try hub.docker.com/_/Ruby, like the one we have on screen. I'm gonna select that to you.
Okay, I got it.
You got it?
/_/.
There. Okay, so if you look at this one, it's oh, what happened? That's my presentation. Did I get unplugged? Did I? Oh.
You probably back to the
Why is it not?
Looks like you just stopped sharing the screen.
No, I know, but I just it's showing me. You know,
You just connect. If that is easier.
there. Okay, and this is the image from where that other image is being built. So let's go back to the original Docker file. For now, let's we're gonna take that. This is gonna build an image coming from another image that already has Linux, Ruby, and everything that it needs to run Ruby 242. This has already been done by somebody else, so we don't have to worry about that. We know that this Ruby 242 image has everything you need to run Ruby. So the next thing we're going to tell it is in line number 4. We're going to define an environment variable that's called application directory, just so that we explicitly say where our application is going to live. And that way we're not relying on whatever default thing Docker will put. Then the next line, in line 7, we're saying, okay, add from the host directory, add everything from the host context where this is running, add everything into this application directory that I just defined on line 4. Right? So grab everything, that's my whole repository, my whole code base, and add it to this web app current. So inside of the Docker image is going to add all of our code. And then finally, we're going to say, okay, the working directory, the default working directory is going to be that working directory. And in line 14, we say, now when this spins up, you have to run bundle install. Sorry, when you're building this image, you got to do a bundle install. So what we did is we provisioned the operating system prepackaged with Ruby, we copied over our code, and we said bundle it, and that builds our image. I'm going to talk about line 16 and 19 in a second. So why don't you guys go ahead and run your first ever Docker command. You're going to do this Docker build -f. You're going to put the path to the Docker file. You're going to define a tag, so we can identify it, and the period so that we can tell it to, I don't know what the period was for, but you got to put it. Yeah.
So build with force from the Docker file.
Actually, F stands for file. You're telling it, use this file, because otherwise it uses the default Docker file that is in the directory where you're running. Jokester.
What does latest stand for?
That is the tag. So tags are used to like version your images. So this is version 1, version 2. You can put a git hash in it, QA_git, any sort of identifier that identifies.
The code that's running in that image.
Not the code, but the version of the code, right?
People use it for versioning, and best practices have it that you should always define the latest so that people don't grab the most version and grab the latest.
Okay. Can you raise the volume there, please? Oh, okay, thanks. So if you guys run it, you're going to notice that first it's going to do some sort of pulling. It's going to try to pull from that Docker hub the Ruby image, and then it's going to start running the commands we told it to do, which is copy over the the code files, then define the working directories and bundle up. So if that all worked, you guys should be getting to this screen. Did you put a period at the end?
Is period part of the command?
Yeah.
Okay.
Jared, do you recall what the period was for?
I think it's full for
What?
Full line.
Okay, so it's the context.
Yeah.
Okay. All right. So after that, supposedly the image was built. So how do we know which images we have where we run Docker images? I can't see. Hold on a second. This thing is blocking me. Docker images. That is going to list all of the images that we have. I built a few. So I'm just going to grep it to Jokester. Oops. Forgot that. So, let's do that again there. So that basically builds the, let me display the full thing so we see the column names. So the first one tells me that's the name of the image. The second column is the tag we assigned with the -t command, switch I mean. An internal ID that daemon uses to identify it, and just when it was created and how much space it's taken in your drive. So effectively, we now have the image. Let's go back to this diagram here. So here's what we did. We had the Docker file, we did a Docker build, and it created the image. When it was creating the image, it might have pulled something from the repository, which was the from Ruby 242 to be able, but right now we're at this stage in which we have the image right there. Okay, so now that we have our image, we have our minimum expression of our application, why don't we go ahead and run the specs? And we're gonna type this command. We're telling it Docker run this image and run this command into that image. So we do that, and we're gonna notice is that it spun up a container, it loaded the image in that container, and then in that image we run this command. We said rspec and it run the specs. Is that running for you guys?
No, I understand.
Oh, okay.
Okay, this is got installed.
Oh.
Well, I was
You're
just
building-
able to build and
Okay, cool.
two examples, zero failure.
So that was being run inside of the container itself. So what it did again is it spun up a container for that image. It loaded the image in that container, the image that we specified, which is Docker Jokester tag latest, and then it run the rspec command in, and then it tore down the container. That was just a one-time run and then tear it down. Okay. Why don't we go ahead? So far, so good. Any questions? Okay. Now, we're going to run this other command. We're going to run the server. We're going to do Docker run mapping port 3000 into 3000 of the container for this image, Docker Jokester latest. So this again is creating a container, loading the image, but we didn't specify a command this time, and it's running the server, right, the Ruby server. You all got to this point?
Why are we putting 3,000 twice?
That is,
I'm sure you were just saying that.
it's actually a good question. So this command is saying, in a nutshell, whatever comes, map the port 3000 from outside to the 3000 that is listening inside. A more proper way would be, I'll answer that question in 1 second. So let's go back to the Docker file, okay?
So we can actually like map. Yes. So I've mapped from my external 4000 port to the internal 3000 port because I've already used my.
No,
3000
that's
port.
perfect, yeah. Okay, so if you guys take a minute to look at the Docker file and screen, in line, actually look at line 19. So what that is saying, the CMD entry says, when this image is run into a container, execute this command, and it's saying Rails server. And we know that when you run Rails server, by default, it uses port 3000. Even though I'm exposing port 80 there, it's running port 3000. So to be able to access the port 3000 in that running container, we have to tell it in here to say, okay, 3000 from outside is 3000 from inside. And if we go into our Chuck Norris application, effectively it is running here. And you can see in the logs of the container that it's actually running the server.
Mm-hmm.
So far so good?
Mm-hmm.
Okay, I'm gonna leave the server running and I'm gonna open another window to show you guys something. So go ahead and do Docker PS. And this is akin to when you guys do PS ops. in Mac to see which processes are running.
Cranky shirt.
Yeah, so what this is showing us is which containers which processes Docker is running, which containers are running. So the first column is telling us, okay, I have one container running that I assigned this ID. The image running in this container is Docker Jokester latest. The command I'm running in this container is Rails server, was created 2 minutes ago, and then it's telling you the port mapping. It's telling you I have port 80 exposed, but I have mapped to TCP 3000, and that's as much as I know of networking. And most importantly, it's telling this container is called, besides the container ID, it gives you a human-friendly ID that is usually an adjective and a noun. And they use sometimes scientist names or whatever. So this is Cranky Shirley, right? So if I happen to go and say Docker kill Cranky Shirley, and I go Docker PS again, there is no container running, and effectively my when the prompt there stopped, and if I go back here, this thing is not working. You guys got that whole thing? So let's go back to what we're doing. So in this case, what we did is we told, go ahead, please.
Of the two 3000s, which one is internal, which one is external? If we are reading it from left to right.
Which one is it, David? Because you just did a 4,000 to 3,000.
Yeah, these two. Let's see. I think it's
The other way.
It's whatever you did. It's the other way.
Actually.
Don't forget to.
Yeah.
Yes. 4,000 is so the left is the external port. The right is the internal port. The Docker port.
The left is the external one, right?
Yeah.
That's what I changed. So this is strange because now I have two Docker containers running, but they are actually separate. So what I did was, in addition to my first Docker run port 3000,
Yeah.
I also wanted to see how a list of Docker containers would look like. So I ran another Docker container
Yeah.
where the external port is 3001 and the internal port is 3000. But because it's a separate container, it will not complain about the 3000 being taken by the other container.
Right.
Okay.
Exactly. Excellent. Because it's two separate, it's a port into different containers. They don't know about each other.
Each other.
They're completely isolated. So,
Feeling good.
great. So if you guys look at that image, that picture there, what we did is we spun up a container with the Docker run and we told it to instantiate that image inside that container. So finally, let's do one more thing. Let's say we want to remove the image because for whatever reason we just want to remove it. So if you guys go Docker images, you're going to see that in my case, in my computer, the Docker Jokester has this 278 blah blah ID. So if I say Docker RMI, sorry, remove image, and I post that ID. Sorry. Oh,
Use by stop the
Good.
container first.
good. So in this case, because there's a container that was stopped, I have to force it. And actually, there's a better way of doing this, which is giving it a directive that once you finish running it, remove the container instead of just stopping it altogether. So just force it, deleted it, and the thing is no longer there. So I'm going to have to rebuild it if I need it.
So RMI minus F.
Has to be by the image ID. Yeah.
And so you have actually using the container. So Docker and say image is being used by container and blah blah blah. But even after doing a force remove, it's not killing. Well, it's not terminating the servers.
Did you
terminate the server?
Right.
Oh, so was that you already did?
Yeah.
Oh, I thought the force remove automatically terminates the container.
Maybe there's a way, I don't know, but typically it's
So kill it first.
yes.
How do you kill it?
Docker kill. First you do Docker PS to list your running containers, and then you do Docker kill and
The container IDs.
yes.
I assume that
Kill it
it's
by the name.
not
You can also.
So mine is like pretty cool.
But I killed it and I am not.
Did you do Docker? Yes.
Oh yes, yes. It happened. It happened eventually.
so then we have to rebuild it if we want to use it.
That's right. Because otherwise it won't know. It won't know the image. The image is there.
So now the Docker removal image. Alright, so everything deleted now. Then go back to the build command to rebuild the image.
If you're gonna rebuild it, yeah.
Okay.
Typically, when you're doing the development flow, you would commit your changes and then build the
Rebuild.
image, or if you're using a different flow, you might be doing your changes in your code and running your tests into your Docker. You're gonna rebuild the image and then run your tests in the image because you want to keep that isolation because you're constantly running against your Docker. There's different flows. But what's most important is that at the end of the session, when you're committing your changes to create the pull request, that everything should be running properly in your Docker container because that's what you're going to be giving to your CI to look at. In other words, the CI is actually going to build that container, run all the tests inside of it as a little black box, and then based on that, it'll then deploy that container. So let's see if you guys can do the following. Build an image and see if you can run a shell command in there. So literally being able to access the inside of the
Container.
container. Yeah.
First, I would have to build the image for that. So rebuild the image.
You might have addressed this, but if we're editing files, do we have to relaunch the image to pick up those changes? Or?
Yeah.
Okay. So Jared, are you just relaunching Docker like 1,000 times a day?
When I'm changing my gem files.
So only if you change the gem files. If you change like a source file, you should pick that
Yeah,
up.
so you can think of the source bit as like a symlink, and the dependencies as like a part of the image. And so in development, what you're doing is you're changing source files normally. I do have to restart my Docker images occasionally when I update those dependencies or like bump the Ruby version. But other than that, it's a pretty simple flow in development.
So that's kind of what Jared's going to teach us in the next session, more advanced Docker, because of course it kind of makes it very cumbersome to every time you're doing a change to have to rebuild the whole dependencies, especially having to wait for Nokohidi and all that stuff. So
Yeah, there are lots of tools you can use to make your life a whole lot easier in terms of the arguments that you're continually passing into Docker, because you can really get on a rabbit hole in terms of getting those commands together, where you're telling it, oh, at these ports, run this command, insert these volumes. You can save yourself a lot of pain and headache by using Docker Compose and encoding all of those bits of information into a Docker Compose file. But yeah, we can go over that next time.
how would you actually shell into the Docker container? Is it like run bash or run Docker?
So
Yeah, you just run it right there, didn't you, Alex, the SH?
yes, so look at the screen, Docker run, you gotta put the switch IT, which means interactive, because
Yeah.
otherwise you don't get to see the prompt.
Mhm.
Otherwise it's being run in there in a session that is just inside the container, you don't have access to it. And you specify the image, and then you say sh for shell. And sometimes it might be bin bash, or it might vary, but typically it's
Yeah, but you have to keep in mind that in this case, what you're doing is you're spawning a new container and you're running SH into it. If you wanted to attach an existing container, that would be another shell command. You have to use the Docker attach. But if you want to use some logs, or if you wanted to attach to a container and use a binding .py, then you, as opposed to, that was a really fun learning curve for me. It was like figuring out that, whenever you run Docker commands, it's actually spawning a new instance.
right. You can also use Docker exec, and it'll go against, and we're going to do that in a second. So, but that's very good information. So let's do LSLA, and actually let's do PWD also to see what's our working directory. So if you guys do PWD, it says, okay, we're in web app current. If you remember when we were into the Docker file, line number 4, we defined that environment variable that we said the working directory and the current directory, and where I'm going to be copying all of those files is going to be web app current. And so as soon as we run shell into this container loading the image, that's the directory we get, and as you see, there's the gem file there, the rig file, all that Ruby stuff is in there. I could even do, I think I can do rspec in here. Yeah, I'm running rspec inside the container. And this is useful for when you gotta, it's like you were using Heroku run console or Heroku console, you're gonna actually SSH into the thing. Yeah.
One thing. So let's say this app had a database and we logged into the console and we ran a rig task that updates records in the database. And in a typical production environment, we will have multiple containers. So from a developer's perspective, when we log into, so would we run rig tasks? Where would we run rig tasks?
That's a great question. So
You could spawn up another container, like you spawn a Docker production instance with like a Rails RAID running, then what it would do is it would have all of the production configuration files. That instance, that new container that you're spawning that is only going to run one command and die, that will connect to the production database, will update all the file, all the database columns, and then it will die.
what's important to take into account is that containers are supposed to be ephemeral storage. They're not stateful. So anytime you have a database service that would be run in a standalone service, or if you containerize it, the volume itself that has the data of the database is going to be a real drive, a real volume, and then maybe the application, the service itself might be containerized. But for the purpose, those would be separate things. You would have one container that has the application that is ephemeral, does not keep state, and then another service, the database another service. And what Jared was describing is, if I have to run migrations, I spin up a container, I run the migrations, the container knows how to connect to that other database, it runs the migrations, and then it's killed. That would be one scenario. The other scenario, there could be other scenarios in which when the container spawns, it first checks to see if migrations are running, it runs them automatically. There's many ways of doing about this. But it's important to understand that they have to be separate. There are separate things.
And I would say it's definitely closer to the idea of a job runner than a dyno, which is this persistent thing that always stays around, and it's like a machine. A Docker container is more of I have one thing to do, I'm gonna do one thing, and then I'm gonna die.
Okay.
So it can either be run a rate task, it could be run a server, but Yeah, they're meant, like Alex said, they're meant to die. Often.
Okay, let's try this now. I just exited from now. I'm gonna spin that. Actually, I'm gonna run the server. Have it around there, and we're gonna do what Jared mentioned, that is attached to a running server. So, if I
For logs.
for logs or just to go in there, so I want to know, did my file actually upload, or is this a different version of the gem file or something like that? So I go Docker+, I have a server running on the container relax swirls. It's the name of the container. So then I'm gonna say, Docker exec interactive against relax swirls. Mesh, I think that's how you do it.
So
Yeah.
this is the Heroku's equivalent of production console.
Yes. So right now it's like Heroku run console. You're actually running a console. Although I have to say that in that case you're not choosing which dyno you're running it against unless you specify the dyno. You have to be running. So in this case, yeah.
Now that about it, I think Heroku's run console is actually more similar to the traditional Docker run command where you're spinning up a new container. Because what happens with Heroku run console is actually it's creating a new dyno for you that is running Rails console.
Oh, I didn't know that. That's cool.
You're not actually attaching to any running instance. You're like spawning a new one. Yeah, it's like kind of similar.
That's actually very good information. So let's take a look at what we're doing. I just spun up the server. I did Docker PS. I have a container running. And then against that running container, I said Docker execute interactively. It's not Docker run, it's Docker exec. I mention the container name, and I say the command shell. And if I do a PS aux in there, I can see that in this container, I got this server running. And just for sanity check, if I do Docker PS in another one, I did not spin up a new instance. I'm attaching to that instance. I can even say, you know, this has some logs. Actually, this. Let's see if I actually do. Here I'm tailing the log file. And if I just exit this guy, I just exit out of that bash session that I opened on the container, but the container is still running. Questions?
Can you change code?
Inside the container?
Yeah.
Yeah, you can do that.
Okay. So
Oh, they're asking
does
you
it
to do that.
simplify hot production fix?
No, that's not the proper way of, I mean, if you have to just check something real quick and just sweep it back, I guess, but the proper way would be to, you know,
Of course, yeah.
stuff.
Look, okay.
But yeah, you should be able, how would we do that? We would
I tried
go-
VI and Emacs. Well, those were not available, but of course there might be some images.
Yeah, typically you wouldn't want to do it that way though. You would want to, like in development, you're, like actually the Docker file, like where you do the add doc / and you're mounting those files into the container. You're creating essentially a sibling. But when you deploy, you don't want to like send code to the server of Docker. You're actually sending the image itself as a Kubernetes so it's being compiled, and you could have no way to update. You wouldn't want to update the source code. What you want to do is you want to create new images for X and then deploy those images to.
I don't have Vim in this image. I would have to do an apt-get
Okay.
except.
Yeah. But this is a good indication, like, images aren't really geared towards, like, live code updates, so, like, down version of Ubuntu that a lot of images are based on don't have a lot of the utilities that you would typically expect to have in that console. Like you would expect to have like wget or ping or all those utilities. Like nothing exists. Like none of that is designed to work inside of this like slim container. So you don't actually have access. You don't have like curl or anything. Like these are very slim operating systems.
And that's the idea, so that you have the minimum expression of what your application needs to run, and you're not using memory
Bloating.
or bloating and unnecessary things. It's the beauty of it, that you can customize it any way you see fit. So we're nearing the end of our first session of 3. The next session, we are going to cover more advanced concepts like Docker Compose. We're going to see more how it's applied into a real project, into a production project. Yeah, one of more
We're
things.
going to cover Kubernetes in the following session, correct?
Correct. That would be not session 3. Once we have the Docker concepts down, we're going to in session 3 we're going to do Kubernetes. If there's space in session 2, we'll do some Kubernetes. Otherwise, we'll do it in session 3.
It would be nice if we could cover the orchestration basics for a bit in the third session, and then talk specifically permitting about the our approach to the new like Kubernetes infrastructure, and like how our applications will fit in that.
Yeah, definitely do that. Okay, any questions, guys, before we have to vacate the room?
Yeah. Is there a timeline when we have to get off of Heroku? Is that really happening?
It is. So company policy is we got Kubernetes and we want people to start moving into it. As per Marco wants both the TK and TB to eventually be in Kubernetes, so that way we only have one way of provisioning and deploying, and we don't have like 3. We don't have like AWS, Heroku, and Kubernetes. It also means the reason we're going for Kubernetes is because it gives us a better handle on cost, because you don't have to be paying for a service on AWS. You're only paying for the provisioning of a big, huge ass machine, and we're taking care of all the orchestration. On top of that, it gives us independence from platform providers. So if one day we get a big deal with Walmart, and Walmart says you cannot use Amazon, we can go to Google Cloud. It's never going to happen. It's an example. If you want to go to bare metal, or if somebody in Guangzhou needs to use something different, this gives them that flexibility to port things. It also gives you more flexibility because in the Kubernetes universe, you can add other prepackaged containers that have other services like logging or monitoring or load balance, other images that are already prepackaged, and you can spin them up very quickly and very dynamically. So it gives you a lot of power on how you provision and build your applications. As far as the timeline goes, the idea is first we're going to get all of our applications on the bump on QA. We're starting from the simplest one. I did avatars, which is the most bare bones, simplest one we have, in my opinion. Once we get that one migrated to Kubernetes, and we migrated the database from Heroku into AWS, and then we can completely hook it out. And this is in QA. We're going to ensure that as a team we know how to deploy these things, how to monitor them, how to log into them, how to do everything we're doing in Heroku. Then we'll choose the next app we'll work on. If it's going to be either web on QA or the API on QA or broadcast, or Guangzhou might have their own set of apps. And we'll start putting them bit by bit on QA. And once we know that everything on QA is working, we have the process down. As a team, we understand it, we will start putting them in production. This is on par of what the whole company is doing. I don't know if any of the apps in the company are in production now. I know that a few are in QA, including the homepage. I think the not homepage is on QA on Kubernetes.
Is that a separate app?
I believe so, yeah.
Not okay.
Yeah, I believe so, but I might, don't quote me on that. But what I do know is that granularly in different teams are embarking on this effort. They're spearheading it, they're evangelizing it. Engineering Productivity is building a whole tool set. They've been doing this for months, and it's a go. So it's not super aggressive, but it's something we should start gathering steam on and getting more acquainted with. Okay, any other last parting